Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. I think the decision has been made on the door. We're going to go with an aluminum door with brass accent hardware. And that is what it should look like if all goes well. I've opted to not allow any of the screws to show. All the screws are on the inside. And there's an awful lot going on here because whatever's holding on to these hinges has got to clear all the internal components. Blow this door off of here for a second, show you what's going on the inside. Can even hide that for a second. There you go. The tall boss on the left-hand side of the internal cutout that I did previously was definitely a screw anchor, and that screw head has to be subsurface because the top hinge that goes on there, it would be this guy here, caps right over top of it. And since there's not enough room on the door to put a screw through it, I had to create a lug on the back of the door and tap that so that we could screw those hinges to it. The hinges actually look like, and by design intent, were supposed to look like, they terminate right at the surface of the door. And I think I achieved my design intent there. It looks like they're connected to the face of the door, when in fact they actually go through the door and there's a lot going on behind it. 2 pins. I'm not sure if I'm going to go with 2 pins or 1 pin because one looks pretty cool too. Let me see if I can do that for you for a second. Let's hide the singles. Put a long one in there. I think the long one looks pretty cool for some reason. I don't know why that is making me smile, but it certainly is. Now, if you were to do a long pin like this, it's been pointed out in some of the comments, good luck getting that sucker in there because the top and the bottom block it off, and the gap on the top and the bottom of the hinge is just not favorable for installation of that pin. So the hinges will have to be affixed to the door, the pin will have to be put in, and then the whole hinge assembly will have to be attracted to the body. Anyway, the door itself is a rotary table job, believe it or not. You look at it and say, well, it's all square. What's the big deal? The only big deal is this sweeping feature right here around where the knob goes. You can't really do that any other way. So when this goes on the machine for milling, I will make sure that the center of this hole right here is over the center of the rotation of the rotary table, do all the square work, and then just simply offset the cutter and walk around that. That should be real easy. Same thing with the 45-degree cutter. 45-degree cutter I'll probably make out of a piece of high-speed steel and grind away the nose so that I can match the radius on the corners in a square move and not have to interpolate the corners on the rotary table as well. All right, that's 3 minutes and 49 seconds of your life you'll never get back. So let's move out to the machine, drop some chips. All right, before the chips start flying, I figure I would show you the drawing that I'm going to use to do this. Like I had said in the past, I like my numbers to represent actual tool positions, tool centers. So I've ghosted some rounds on here. You can see that they're little gold circles, and that represents the same size as the inner radius on the corners. I'm going to be using a 1/8 end mill, 126 end mill, 124 end mill, whatever, and the handle shaft hole is the center of the world. So all my dimensions are given from that feature right there, because that feature is going to be over the rotary table center so that I can do this sweeping round here. All these corners are the same. All these corners are going to be just formed with the end mill. The outside of the part, the profile of the part, left, right, up, down, in, and out. Red dimensions. Keeps it easy to look at. And the inner pocket is all the blue dimensions. And in case I forget, there it is right there. Senior moments happen. You know how that is. If you don't, you will. Anyway, there's the side projection view of it. I'm starting off with a piece of saw cut pookie right here from the shelf. All I did was establish 2 parallel sides. I'm going to go over and let's set up the rotary table. Eyeball where that's going to go right there. Literally eyeball it. Set the digital at 0 and off we go. Should not be a very big deal at all. Let's go. First step in any rotary table operation naturally is to get the spindle of the machine true to the rotary table itself. Now I see a lot of people, and for years I did it this way too until I saw someone do it this way and it made perfect sense. You are not setting up your setup true to a stationary feature. A rotary table is a dynamic environment. So it's the motion, it's the axis of the motion that is critical to align with the machine. And the only way to do that is to actually engage that motion and sweep the spindle this way. When you have 4 zeros on your indicator, your indicator isn't stuck or broken, you know that the movement of that rotary table is true to the axis of the machine. So for all of you naysayers and negative Nellies out there that are going to say, how do you know the outside is concentric to the inside, which is really the important part? Well, because I indicated that first. So I know that the OD of my spindle is true to the ID of the spindle, where the R8 column sits. Keep this in mind, guys. It's the motion of the rotary table to align to the spindle of the machine that's important. If you've never tried this, try this. And for anyone that's going to leave a comment in the comment line, this is a phase 2 rotary table. It is a 10-inch rotary table, and at all times when my dial over here is on 0, that back fence is true to the world, so I can go in any orientation and make the setup that I need. Today the orientation will be 90 degrees to the table, so it will be aligned, a 0 alignment with the y-axis. Let's pop a vise on here and start making the setup work. Remember this one, that's a good one. It's always a good idea when establishing the original or initial concentricity with the wiggler that you do it with a closed loop, and if these things whip out under a high RPM, they can do a lot of damage to your fingers. Now with the rotary table directly under the spindle of the machine, I can legitimately line everything up by eye. The part that I'm loading in here, I've already taken a black Sharpie marker and laid out basics of the part, where the hole for the knob is going to be, how wide it's going to be. And the tall, the height of the door is really not critical. I know it's going to fit within the blank that I'm using. That last cut was a rough perimeter cut. It's about 10 thousandths of an inch off the finished surface in every direction and a little bit deeper than the finished profile. Now for everybody that's going to say, hey Joe, you got some good eyes there, buddy, you only missed the center of that block by about 100 thou. That's because I have double parallels on the back side, and when I drill that hole, if I was shifted over on center, the hole would have hit the parallel. So look ahead about 9 steps when you're doing something like this, and you don't want to oops at the very last minute. Of course, the material is thicker than the final part, and you could do a blind hole, but I've always found a through hole is much easier to ream and get the size. All right, so let's drop the cutter down. Well, let's take away that 10 thousandths and finish the outside, and then we'll dust cut the top so all the other features can be controlled accordingly. And I'm going to start in the corner as not to leave a mark. Now, I've been asked in the past, why do you use coolant sometimes and sometimes you don't? Well, if I think the cutter is going to pack up, then I'll use coolant on the cutter or lubrication on the cutter. And if it's a finish pass, I definitely want to use lubrication on the cutter because it just keeps the chips flowing, keeps a nice sharper edge, and gives you a much better finish. I'm going to take one pass around the top, staying very close to the edge, about 100 thousandths of an inch in, just under the diameter of the cutter, and establish the face of the part. That'll be my Z0, and everything from that point forward, the cutter will move down into the part and remove the material that's not faced off. There's really no sense in decking this whole part right now because the deck is going to be subsurface. Only cut the material that you have to cut. It is a time saver. Let's do it. Just a quick double check to make sure that the initial depth cleaned up the surface. I'm going to move back over to the front now, right on center on the x-axis, and I'm going to clean up this area that will be the elevated section for the knob. Upper face being established, I'm going to zero out my knee dial right here, my Z-axis, and I'm going to make sure that all the clean surfaces that I just did are now the 0. So let's do the inside pocket, leaving a square boss here, and we'll finish that off on the rotary move. If you pay close attention to how this cutter is moving right now, watch this. It is actually going down as it's going across. This is not a center cutting end mill. And that's a ramp cut. And like I believe I state some other time in this video, that takes a tremendous amount of load off the center of the tool and reduces the chance of exploding the tool if it's not a center cutter. Now, I am not a big fan of stopping the cutter while it's in a pocket, but I moved the cutter off the X and Y walls so we could get a better feel for what's going on. And, you know, with the reflection on that, it is really tough to see what's going on. Let me knock the center out of that, and we'll get a better feel for what's elevated and what's not. There's an awful lot of lines going on there, but the outside of the door is finished, left and right, forward and backwards, X and Y axis. And then there's about a 70 thou ridge cut into it all the way around. And now I got to remove all of this material on the inside. This area right here, as I spoke about before, is the ramp cut. If the cutter is not a center cutter, by all means ramp it down. Raise the table as you're getting to depth instead of blowing up the end mill from the pressure. The rest of this is just going to be removed by eye. Then I'm going to move down to my final thickness, or my final depth of the pocket, and take everything to its final configuration. I hit the elevated sections of the pocket with a black Sharpie marker off camera so you could get a better feel for exactly what's going on here. You can see the perimeter's done, the area where the knob's going to go is done, and the recess in the middle is almost done. I'm going to take my time with the recess in the center. I want to leave a relatively good finish. It is going to be blasted anyway, but I don't want to leave any dig marks. And the potential for a dig is elevated at the corners because that's where you make the most contact with the cutter. For the most part, it's a very small chord of contact as you do the wall, but as you get to the corner, that increases to a 90 degrees, or 1/4 of the cutter is making contact when it hits the corner. So slow down at the corners and take your time. Let's do it. This is a very superficial pass inside the pocket here. And I'm making nice long lines, making every attempt to get a good finish on the bottom of this pocket, because when I'm done, I will emery the lines out of it and Scotch-Brite the lines out of it just to see what it looks like. And the more you change direction with a cutter, the higher the odds are that you're going to have a end mill footprint in the bottom of your detail. So with the perimeter finished, I'm going to double back over that one wall and just take small steps going completely lengthwise. I know what the setting is to the top of the small protrusion there, so my pass will pass within that. And then I'll just knock out the two rectangles on either side of that. I cut my lawn the same way. Pocket is complete, perimeter is complete, the width of the boss is complete, and there's a little extra space, little extra material on the outside. So when I make my radial sweep with the rotary motion, it cleans up and there's no flat spot on the outside. Now bear in mind, guys, normally with the rotary table, the table will turn in the direction that the crank is turning. That doesn't necessarily translate to the direction that you want the cutter to go, so think ahead. If I want to climb cut around this boss, starting from the other side, I want to climb cut around. That means the table has to move counterclockwise. So when I get to my number, I have to turn that dial counterclockwise 180 degrees, or I'm going to have to go get tissues and cry for about 3 hours because I just blew this part. All right, there you go. The only way to do it, right? That's just to do it. Hit it. There will not be a whole lot of load on this cutter when I interpolate this round around this feature right here. However, the load on the cutter is different than the load has been on the cutter for the majority of that pocket. So expect a halo around that boss when you're done from cutter flex. All right. The width of the pocket was formed with the x-axis shift 0.173 off center when I returned for the sweep of the radius, so that I did not leave a vertical dig mark on either side of that feature. I stopped the X table at 175, about 2,000 short. So doing that, you're going to see about a 5 degree rotation before any chips start to fly. But that's what I chose to do. Didn't want to leave a mark. Big on not leaving marks. Unless, of course, your name is Mark, in which case I didn't do it. I'm going to take a drill blank. Now I'm going to grind a 45 degree cutter, and I'm going to come around and I'm going to retrace exactly what I just did so that I can get that nice chamfer on the inside. Then we'll drill and ream the hole. Be right back. This is the tool that I'm going to be using. It is ground on the back side of an extended center drill, 1/4 inch in diameter. It's about 6 millimeters. Really not all that hard to make a tool like this. Grind it halfway back. I did this on the side of a pedestal grinder. Grind it halfway back from the diameter so it's 125 thick or less. Less is better. Then grind the profile on it that you want. In this case, it was 45 degrees on one side. In order to mimic the 125 diameter cutter that I used to mill the pocket, I'm making sure that the center of my tool is about a 50 thou beyond center in that direction, because this chamfer does not go all the way to the bottom of the pocket. Little back relief on it, just like you're grinding a lathe tool. And from the point of the tool on the opposite side, you don't want a 45 degree. You want a greater angle so that it is a natural draft. This is a single lip cutter. It's going to be used in a collet, and I'm going to walk around the pocket with the same numbers that I used to create the pocket. I'm going to start this cutter at the corner with an X and Y dimension dialed in perfectly, and then just move up with the table to establish the chamfer that I want. That is the easiest way to do this. All right, let's give it a shot, and hopefully it doesn't rub too bad. I don't think it will. Let's give it a try. The one thing that I absolutely do not want to do when chamfering the inside of this particular tray right here is to leave a scratch where the tip of the tool is. So I'm going to set my maximum depth just with a piece of Post-it paper. And I'm going to zero my Z on my knee. Zero the Z on the knee. Sounds like a song, right? Okay, so I'm at 0 right now on the knee. I'm just feeling a light drag on this piece of Post-it. I'm going to put the center of the tool in one of the corners on location with the exact same numbers used with the 1/8 inch end mill. I'm going to raise the cutter up first. Table is 0. Stop on set on the quill. Moving up. Moving up. Rotary table is back to 0. And going 4. That tool is currently positioned right directly over the corner, the same coordinates used with the 1/8 inch end mill. Now I'm going to come down with the quill to the stop on the quill, but I'm going to drop the table first. Okay, I know my 0 on the dial is as high as I can bring the table, so that's my little safety margin. I'm going to drop the table 100 thou. Watch it go down. I'm sure you're going to see the gap between the tool and the part drop. 1 revolution. And I know that revolution is greater than the chamfer that I'm going to put on there. So now I'm going to come down with the tool to the stop. Bear with me here. I know this is kind of confusing, but bear with me and you're going to like what you see. When I raise the table after the cutter starts, it might be a little bit loud. When I raise the table, I'm going to raise the table until I see a witness mark in that corner. At that point, I can come up the desired chamfer, but I can't go any farther on the knee than the 0 that I previously set. So as soon as I make contact, I'll have a visual on the dial of how much room that I have to play with and whether or not I can accomplish what I'm looking to accomplish. All right, that being said, let's make some chips. Using an eye loop and some black Sharpie marker can guarantee that you can see things a little bit better. It is very difficult to see from this angle, but you'll see it when I run along this backside. That cutter just made contact with the full radius in that corner. I am 35 away on my dial, and I need an 030 chamfer, which means I have plenty of room and I will not bottom the cutter out. So here we go. I only plan on going around the inner profile here 1 time, and this is a finish pass. So I am going to use lubrication on this, and I'm going to take my time because with a single lip cutter, if you go a little too fast, you get that railroad track looking finish. And this is a highly visible surface. It may be polished a little bit, but it's easier to polish something that looks nice to begin with. And I'm going to do it the exact same way that I did with the round feature. I'll come back and I'll do that at a later operation. I guess down here in the corner is probably your best look at it from this orientation. Everything being so shiny and contrasty like that, it is really hard to see. I'm going to come back and reset the tool on the y-axis center, and I'm going to step off and rotate the part and finish the chamfer around the door handle lug. And the final chamfer inside the pocket is the chamfer around the doorknob feature. Counterclockwise on the dial. Part is not returned to the original orientation. Just going to drill and ream the center hole, and then I can bandsaw all this excess off and flip the part over. The initial perimeter track was a little bit deeper than the material that will be left behind, but the part will be considerably thicker because of the step in for the recess of the door and some of the lugs on the back for the hinges. So it's okay right now. I'm going to take this over to the bandsaw, saw off all this waste material, and when I put it back in that little vise, I'll be able to grip on clean material on parallel surfaces. Right back. Ran a little bit of emery across the inside to get rid of the cutter marks. Cleaned it up a little bit, put some of that blue magic polish in there on a rag. That came out pretty good. Now it's time to flip it over and put all the steps in. There's a bunch of work and it's going to have to happen to the back. And this little guy right here is the center of the universe. When I flip it over, I'll indicate that pin, reestablish my XY0, and I'll know exactly where I'm at in relation to the front. Let's see if we can get that done. If you've tuned in for some of the other models that I've built, you've seen me do this before. I'm a big fan of aluminum inserts on a small vise like this, or aluminum soft jaws on the larger vices. You can really get away with a lot of things that just are real head scratchers when you're allowed to run the cutter into the jaw. And it's always good when the jaw is aluminum and not hardened steel. The aluminum inserts that you saw me put in there and true up initially acted for two specific reasons. Actually, the first reason is they are parallel for the perimeter cut that I established when I did the front. Second reason is I know that how much material I'm gripping on right now is more material than the finished thickness. That way, when I get down to my elevated feature back here, I will be sub-jaw, and if I hit the jaw with the cutter, well, that's not a good thing. So now that I have the aluminum inserts, I can go all the way around this piece below jaw level and still maintain a good grip on this piece and get the thickness I want. This pass that I just made is a Z0 pass, and I know what the steps are incrementally going down to the finished perimeter. Everything is going to work from that hole that I just indicated. And we're going to fast forward this a little bit and make something happen. This initial feature on the door, the lip, the bottom of the cutter right now is forming the surface that will come in contact with the casting when the door closes.
And I think you can see the benefit of the aluminum insert right now. I am well into those aluminum inserts. Leave a couple thousandths behind for the finish pass and clean them up. There will be two small projections on the back of the door that will receive screws for 1/2 of the hinge for each of the two hinges. There's an awful lot of whittling going on here and a lot of numbers that you got to pay attention to make this happen. And sometimes it's just easier to isolate a couple of features, a couple of islands, and use the exact same number. If you have a number locked in your head, well, that's the number that you go to. Just move left and right and finish off each side each time.
Next step in the process is to knock the black corners off so that the door will close and mate with the internal rounds on the cavity that you saw me mill into the base. This is going to be a concave feature. It's going to be a scallop on all four corners. Now I could set this up on a rotary table and take the time to round all four of these corners off, but you know, that's got to draw the line somewhere, guys. I would have to move this vise around 4 times in order to do that, and this is an invisible feature. I know I should do it. I may kick myself for it someday, but that day ain't today. So just stay tuned, and I'm just going to knock these corners off.
The best way to do a feature like this is to do it at the same time that the adjacent lip is formed. Now, I didn't do it at that time because I just wasn't sure how I was going to do it. I didn't know if I was going to put radiuses on these corners or do exactly what I'm doing here. This is an 093 corner round relief. It's a 3/16 end mill, and it's an 060 radius on the frame of the part, so there's going to be plenty of clearance.
Well, it never fails. Anytime you're trying to film something, inevitably the memory card is going to take a dump. I don't know whether or not you got all of this or not, but this is what the back of the door looks like. These will be notched out so the hinges can pass through the door and look like they're sitting on this surface when they're really passing all the way through. Drilled and tapped in this orientation. And the knob will be scalloped and brass, and so will the hinges. Thing of beauty is joy forever. I don't know if I'm going to blast that or what I'm going to do with that. It's just kind of pretty the way it is. I'm going to leave it be for now. And that is all I got for you guys. This was labor of love today. This was a lot more work than I had anticipated. I do have to adjust the projection of the shelves as well to clear all this stuff on the inside. But this was engineered to miss the shelves with the hinges. So it's just going to be a minimal front relief on the shelves in order to get that to work. Well, there you go. Voila. Wave the magic wand and now we have a door. I like it. About $5,000 worth of clearance on there. Hopefully it'll be $5,000 worth of clearance when I get the hinges done. Who knows? Anyway, thanks for tuning in, guys. I appreciate you spending some of your time with me today. And like I always say, wherever you are in the world, I hope you're well and happy and safe, all of the above. I am Joe Pye at Advanced Innovations in Austin, Texas. I'm out.